Welcome to Train Signal. You're watching a lesson on DHCP. Now there's a term you probably have heard before. DHCP is talked about all over the place. But what is DHCP? Well, the first thing you need to know is what the letters stand for. The letters stand for Dynamic Host Configuration Protocol. And if you think about it, well, that's really what it means. It means that we are going to configure our hosts dynamically. And I guess because we have to use the last word, it's a protocol. But the bottom line is DHCP gives us the ability to avoid having to go around and manually configure every computer's IP configuration. Now, we'll talk a little bit more about the why this is so important. But first, let's learn how the computers actually get those IP addresses. So when it comes to clients obtaining a lease in DHCP, the first thing that you need to make sure that you understand is that there's a word out there I want you to remember, and that word is DORA. D-O-R-A. But DORA, it's not really a word at all. It's actually an acronym that stands for the four-step lease process. Okay, so we're going to go through each of those four steps. And the first one is the letter D in DORA. The D stands for discover. And I will tell you that that's an official term. Like if you were to go all the way to the extent that you were monitoring the network, if you were looking at all the different packets that were traveling around the network, during this discover process, you would see something called a DHCP discover packet. Now, what is the purpose of this packet? Well, the purpose of the discover packet is a client attempting to locate the presence of a DHCP server. So you have a client that looks at its configuration and says, well, I'm set up to automatically obtain an IP address. And in order to do that, well, I hope to find a DHCP server. So what I'm going to do is I'm just going to broadcast out across the network, hey, I need an IP address. Is there a DHCP server out there that can help me? And that's the actual process. That's what the discover process is. It's a broadcast from a client saying, I need help. Is there a DHCP server out there that can help me? Now that moves us into the second step of the DORA process, which is the letter O, which stands for offer. Any and all DHCP servers that receive that discover packet, okay, so you may have more than one DHCP server on your network, and we're not going to go that deep into this, like how you would set up multiple DHCP servers to work with one another. So we'll just say that there's one for right now. But if there was more than one, then they would all go ahead and send back an offer packet. Or to be more specific, it would be a DHCP offer packet. And it's a DHCP server offering up an IP address. So it's the idea of a DHCP server saying, well, yes, hello there, client. I'm a DHCP server. And I've looked at my database, and here is an available IP address if you'd like to have it. So now the third step of this process is the R, which stands for request. See, because the problem that we have here is just because the DHCP server has put out that offer for an IP address, if you did have more than one DHCP server, the client, well, it can only have one IP address. So the DHCP server has no way of knowing just from that offer of an IP address whether it's going to be used or not. So to continue through the process, the client will then request that address. So we have, just to kind of review, and I'll do this a few times, I want to go back to the beginning. You have a client who first just says, hey, is there a DHCP server? You have a DHCP server, or maybe more than one, who says, why, yes, here I am, and here's an IP address if you want it. The request step is the client saying to either the one DHCP server, if that's all there is, or to the first DHCP server that it saw an offer from, it responds back saying, yes, I actually would like that IP address. Thank you very much. Okay, so it's making a request saying, thank you for the offer. I would like to request that I get to keep this IP address. And this, again, is a direct communication now between the client and the one DHCP server. So the one DHCP server knows that the client is directly dealing with it now, whereas if there were multiple DHCP servers, any other DHCP servers that did not get a response back to its offer, they just basically say, oh, well, all right, I tried, and they put their IP address back into the database. So the request is made of the DHCP server to say, yes, I would like it. Are you sure? Can I still have it? And that brings us to the fourth step, which is where the DHCP server will then send what's called a DHCP ACK, which stands for acknowledgement. Okay, and that's where the server acknowledges and then truly at this point issues the lease. Okay, so it's only once we get through the entire DORA process that the server now knows that this client is going to have a certain IP address and is going to have it for a certain amount of time. And the client now knows I am allowed to have this IP address and will go ahead and configure itself to use it, and again, for a certain amount of time. And that's why we call it a lease, okay? Because you're just leasing it. You don't own that IP address. You're just leasing it. And that lease can be set for a certain duration based upon the setup of your network. And in a few minutes, when we go in and take a look at some stuff, I'll show you where that lease duration can be set. Now, speaking of a lease duration, this right here that we've just gone through, this whole DORA process, that's what happens when a client does not have an IP address and it needs to begin the entire IP address lease process. But once it already has an IP address, when the lease is up, and I'm going to explain to you in a little bit more detail, it's not exactly when the lease is up, but at some point before the lease is up, we'll say it that way, at least for right now, there needs to be a renewal process, right? Because the client has an IP address. It can only have that IP address for a certain amount of time. And when that time's up, well, now what's the client supposed to do? It no longer has an IP address. So we need to have a renewal process. And the renewal process is much simpler than the original lease process. It's only a two-step process, and it's just RA. Okay, so if we have DORA, well, now we just have RA. We have the last two steps. And the reason we only need the last two steps is because the client doesn't need to look for the presence of a DHCP server. It doesn't need to find one. It knows about the DHCP server. It knows who gave it its IP address. So that whole discover and offer process doesn't have to happen. All the client has to do is send a request directly back to the DHCP server to say, hey, you know what? My lease is going to be up soon. Can I renew and get a brand new lease and keep this IP address? And then assuming everything is up and running and working in place with no problems, the DHCP server will then respond with an ACK, which is an acknowledgement saying, yes, you can have that IP address for a longer period of time. We're going to renew your lease and start that process as far as the duration all over again. Now, I mentioned that it's not exactly at the end of the lease. And to be more specific, I can tell you that this renewal process happens at every half-life of the lease duration. So, for example, if the lease was, let's say, 8 days, which in Microsoft DHCP servers, I will tell you that that's the default setting if you don't change it. And again, we'll look at this in a minute. But let's say that lease duration was 8 days. DHCP server has given a client an IP address and says you can have it for 8 days. 4 days into those 8 days, so at half of its life, or half of the life of the lease, it's at that point that the client will attempt this renewal process. If the DHCP server is available, after 4 days, the client will renew and the server will say, no problem, you've got a fresh 8 days. And then, of course, 4 days later, this happens again. And if everything works, you get a fresh 8 days. And that process just continues, essentially forever. But what if the DHCP server was unavailable? Whether it's that the client just can't get to it, or maybe the server is down? Well, in that case, what will happen is the client will continue to use that IP address because it says, well, I have 8 days. It doesn't matter that 4 days have passed and I can't get a hold of my DHCP server. I have 4 more days. And so the reason I say it's every half-life is because what the client will do is it'll say, well, now I have 4 days left. What's half of that? 2 days. So when 2 more days have passed, I'll go ahead and attempt again I'll say, hey, DHCP server, are you back up yet? Because I want to renew and get a fresh 8 days. And if the DHCP server is up, then the client gets a brand new lease. 8 days starts over until another 4 days goes by and we start the renewal process again. If the DHCP server is still unavailable, the client will still go ahead and keep that IP address because there's still 2 days left. And then it'll look at, well, what's half of that life? And that's 1 day. Okay, so when 1 more day has passed out of the 2 days, it'll try again. And this process will continue for every half-life until we get to the point of 87.5% of the lease duration has expired. When we get to 87.5% of the lease duration passing, if the client is unable to locate the original DHCP server, then it will attempt to renew with any DHCP server. Okay, so it'll go out there and try to find another DHCP server who maybe has taken over this particular pool of IP addresses and attempt to renew with that DHCP server. And again, anywhere along the way that this is successful, great. Brand new lease, new 8 days, good to go. But if that attempt still fails, then what the client will do is it'll just go ahead and hold on to that IP address until it has truly exhausted the full 100% of the lease duration. And at that point, the DORA process starts all over again, meaning the client has lost its IP address. It goes back to the D in DORA and says, hey, I'm just a client out here looking for an IP address. Is there anybody out there to help me? And hopefully there is a DHCP server to answer. Otherwise, you have trouble, right? So that's how the lease process works from the beginning as far as DORA, and then how the renewal process works with just the RA, or the request and the acknowledgement. Now let's talk a little bit about why we would use DHCP. I mean, what's the whole point of this? Right? I mean, why do we have this whole process in place? Well, I'm going to use a hypothetical scenario here, and you'll see that this scenario is not quite as elaborate as many of our other enterprise environments might be. I will tell you that this scenario has been pulled directly from some of my other courses. I have a number of other courses where there's a fictional company named Globomantics, and this is the scenario that I have here. Is this company, Globomantics, has a headquarters in New York where there's more than 500 computers, a branch out in Chicago with over 80 computers, another branch in Tokyo with over 50 computers, and a small branch in Dallas with about 10 computers. If you do the math and put this all together, we are now talking about an organization that is a worldwide organization. So that's the first component you need to keep in mind, right? We have computers all over the world. And then we have over 600 computers all together. And so if you think to yourself, how would I want to configure all 600 computers in all these different locations around the world? If we had to do things manually, that could be quite the chore. And not only would it be a lot of work, right? Not only would you have to actually go out to each office and you'd have to go to each computer and you'd have to set everything up manually, but what about the risk of making a mistake? And then when you make that mistake, right? You go in, you key punch the IP address in, and you only find out later on after you've left the office that somebody's computer's not working because you misconfigured it, or you accidentally put the same IP address on 2 different computers, or whatever the case might be. You may have to even travel back just to fix a problem. I mean, it's crazy. So now there's another aspect of this. I mean, not only do we have, just the difficulty of having to go to all the different machines and set them up, not only do you have the potential for making a mistake, and then even if you make that mistake, it's not just that you made a mistake, but you might find out about it later and then you have to go back. But then add on top of that, what if you don't make any mistakes? What if you make the effort to go to all 4 of these different offices all around the world, you set up every computer, and everybody's working perfectly? Well, sometimes things happen, right? Things just break. Maybe somebody had some privileges they weren't supposed to have, and they went in and reconfigured something. Or maybe just a system, some way, somehow, something went crazy with it. There's all sorts of different things that happen. Well, now when it comes to troubleshooting, you have to possibly travel out to that office again. So I think you're getting the idea here of why we would want to use DHCP. We want to be in a dynamic environment where everything is just set up for us, right? You just manually configure a server in one place, and then everybody else just gets their stuff. And we know that they're going to get it correctly. We know there's going to be no IP address conflicts. And we know it's all just going to work. And when it comes to troubleshooting, you have all of your information as far as who has what IP address and this and that, all stored in one central database. So you just go to that one database, you look things up, life's a lot simpler. All right, so what I'd like to do now is I'd like to take you over into a Windows Server operating environment so that I can show you specifically how to set up a DHCP server. Let's go take a look. Okay, so what I want to do here is I want to actually show you two different ways of setting up DHCP for your network. Okay, these are two of the most common ways out there. The first thing is, well, before we get into any of this, I just want to explain the desktop that you're looking at. This is nothing more than a Windows Server 2008 computer. Okay, yes, there is other configuration that's been set up on this machine, but it has nothing to do with anything that we're going through here. It's just a Windows Server 2008 computer. And the reason for even having that is pretty much just one of the two ways that I'm going to show you how to set up DHCP is on a Windows server. Okay, now that we have that, what I want to first show you is how to set up DHCP on a typical Soho router. Okay, because remember, here in my office I have a Linksys router, and I do actually use it for DHCP in my office here. So I'm not talking about train signal as a whole. I'm saying in my one little office here, for the computers I have here and for the virtual machines that I use this little Linksys router. So how do we actually set it up on that router? Well, we do it through a web browser. So I'm going to go ahead and click Start. Just go to Internet Explorer. Once in Internet Explorer, go ahead and type in the IP address of the router, which happens to be 192.168.10.1. It then asks me for my credentials, so I'll go ahead and enter those now. And I get into a setup screen. I will tell you that no matter what router you're using, whether it's Linksys or Netgear or D-Link or whoever you might be using, typically right here on the very first setup screen, okay, so we're just under Setup and Basic Setup. Let's scroll down a little bit here. You'll see here that I have DHCP server. And then I get to choose whether I want it enabled or disabled. Believe it or not, it's really that simple to set up. You just click Enable. Now, there's a couple little pieces of information you need to add beyond that. Okay, so besides just turning on the DHCP server functionality, you have to give it a starting IP address. You'll notice it assumes the 192.168.10 network. And the reason it's assuming that is because it knows that that's what network it's on. Right? The local IP address for this router is 192.168.10.1 with a subnet mask of 222.55.0. So it assumes, hey, I'm going to be handing out IP addresses on my own network. So I just give it a starting number. Okay? That's literally just the first IP address in the pool, or what's known as the scope, that we're going to be handing out. Then from there, I have to decide how big I want this scope to be. So you'll see here it says maximum number of DHCP users is 50. And so what those two numbers mean, once I put in the 100 here and the 50 here, it means that we're going to hand out the IP addresses 192.168.10.100.101.102, all the way through to .149. Okay? We're going to hand out those 50 IP addresses. Then I can go ahead and I can set up the lease duration. Remember, clients only get their IP addresses for a certain amount of time. So I can set it up for a certain number of minutes, and if I have it at 0, which is what it defaults to here, it means 1 day. So this Linksys router is handing out IP addresses, and it's giving them out with a lease duration of 1 day. And of course, we just learned that that means that those clients will come back after half a day or 12 hours to attempt to renew. Then from there, we can hand out DNS addresses. So if we want the client to use a specific DNS address, we can put that in here. If we want the clients to use a specific WINS address, we can enter that in here. If you are not familiar with what I'm talking about when I say DNS and WINS addresses, don't worry about it. For right now, basically, I just want you to know that This is a little bit extra configuration information that can be programmed into a client's IP address configuration. And I will tell you, there is one other piece of configuration information that this DHCP server will hand out, and that is for every client that it hands an IP address to, it's going to assign it a default gateway. And the default gateway is going to be right here. It's going to be this router. It's going to be 192.168.10.1. Because basically, this device is smart enough to say, hey, I know I'm a router. I know I'm handing out IP addresses. And if they want to get out of their network, they probably should come through me. So I'll set myself up as the default gateway. All right, so that's how you would set up DHCP in a Soho type environment, a small office, home office type environment with one of these Soho routers like the one I have here. Now let me close out of here. And now let's jump into the Windows Server side of things. Now I will tell you that there is one piece of configuration that I did do on this server that if you're trying to follow along, right, if you've taken the time to install a Windows Server 2008 computer and you're trying to match yourself with exactly how I'm set up here, I will tell you that you're going to need to install the DHCP role. Now, I'm not going to go in and show you how to do that because that's outside the scope of what we're trying to do here. But if you are familiar with Windows Server 2008 and you know how to do that, feel free to give it a shot. Once the role has been installed, all you have to do is click on Start, go to your Administrative Tools, and there you will find DHCP. I'll expand this out. Again, I will emphasize, don't pay any attention to the name that you're seeing here. That's just the name of this computer. It was taken from one of my other courses, actually. All right, there's that Global Mantics name that we've seen in other lessons. You'll see here that DHCP can be used on a Windows server for both IPv4 and IPv6. We're not going to worry about looking at the IPv6 portion because Windows Server gives you the ability to set it up so that it's completely automatic and dynamic. There's literally nothing for me to do. It's already working without me setting up anything. Under IPv4, you'll see that I don't really have anything. What I'm looking for here is something called a scope. And there is no scope because I haven't installed one yet. So let's take a look at that now. I will right-click on IPv4 and select New Scope. This is how you set up the actual range of IP addresses and any additional options that you want to go along with it. So I will click Next. I'll give it a name, so we'll just call it Demo Scope, right? This is just a hypothetical. I'm not actually using this. I'll click Next. By the way, for the name, you would typically give it a name that makes sense to whatever it is that you're trying to do in your network. Maybe if there's a certain network that you're looking to hand these IP addresses out to, or maybe a certain department or a certain room or whatever, then you would name it accordingly. In this case, I just named it Demo Scope. Now here's where we actually give the IP range. So we're going to stay in the 192.168.10 network, right, because that's what we're on. So I'll put in 192.168.10, and then we're going to go ahead, and since my other DHCP server is already handing out 100 to 149, I want to make sure I don't conflict with that. So we'll start at 150, and then we do an end IP address of 192.168.10, and I'm going to go all the way up to 250. So we're going to hand out IP addresses from 150 to 250. As far as the subnet mask, here it is, 255.0. This 24 right here, under the length, if you've watched the IP addressing lesson, you've learned about CIDR. That's the CIDR notation for a subnet mask of 255.0. I'll click Next. Now this is where I can set up something called exclusions. And this is very important because if I'm going to hand out IP addresses from 192.168.10.150 through 250, and I happen to know that I have some servers set up here in my office, and they have been statically assigned certain IP addresses, and it's within that range, I need to exclude them from the pool. So I'm going to say 192.168.10.200 through 192.168.10.210. We're going to say that those, and I have to make sure to click Add, that's very important, those are going to be excluded. We don't want to hand those out. So what this means is we're going to hand out from 150 to 199, and then from 211 through 250. Those are the ones that we're going to be handing out with this scope. We'll go ahead and click on Next. Here's that lease duration. It defaults to 8 days in Microsoft World. Click Next. And then I have the choice to now configure additional DHCP options. And this is similar to what we saw on the Soho router. I'll show you. Let me go ahead and say yes, I want to configure these. Click next. Do I want to assign my clients a default gateway? And I'm going to say, well, yeah, I do. I want to point them to 192.168.10.1 so they know how to get out of the network. How about DNS servers? This happens to be the IP address of a couple DNS servers and the name of the domain that I'm working on. So I'm going to say, all right, there's the name and DNS servers. Next. I don't have any Win servers, but that's another type of server that you can tell the clients to look to. But since I don't have any, I'll just click next. And do I want to activate the scope? Because it is possible to create a scope but in Microsoft world, but not have it live, not have it active. Just have it ready to go, and you would activate it when you need it. I'm going to go ahead and say, sure, let's go ahead and activate the scope now. And finish. And now I have a scope. And if we look at this scope, you'll see there's a number of items we can look at. First, we have the address pool, which shows us 150 to 250, but we're excluding 200 to 210 out of that range. This next item here, address leases, is where we could see the actual leases that have been given out. So as clients turn on and say, hey, give me an IP address, we would see them listed here. It's a great way to just kind of see everything in one central spot and see what computers have been given what IP addresses, especially if you see a certain IP address is creating some kind of traffic that you don't like or understand. You want to know, well, whose computer is that? It's a great place to come in here and quickly look and see that. I'm going to skip reservations for just a moment. We'll come back to that. But first, let's look at our scope options. This is where you can see that we set up our router or our default gateway, our DNS servers, and our DNS domain name. Now, if we jump back here to reservations, this is the one last thing that I want to show you because a lot of people get exclusions and reservations very confused. And the reason is because they both have to do with static IP addressing. See, the exclusion is used when we have certain IP addresses that are already being used statically, and a good example of that would be for your servers, and you just want them flat out excluded from the range of IP addresses that you're handing out. Whereas a reservation is where you have a device, and the example that I'm going to use would be a printer. Printer is a very common device to give a reservation to. When you have a network printer, so a printer that sits out all by itself, it's not plugged into a computer, it has a network card, so it exists on your network. If you've ever gone in and tried to configure the IP address on the printer through its little manual setup window, you know that sometimes it's a real pain in the rear end. So what's convenient to do is to go ahead and let the printer remain a DHCP client, which it usually comes by default, by the way. And then we come over here and create a reservation so that we always give the same IP address to that printer every single time. Now, why do we do that? Well, because our clients, very often, in order to find the printer, need to know what its IP address is, and they'd rather it not be a moving target. So in order to create a reservation, I'm just going to right-click and say New Reservation, and I'll give it a name. We'll say Demo Printer. We'll say that the printer, we want it to be 180, right? We want it within the scope. We're handing out 150 to 199 and 211 to 250. Within that scope, I want 180 to always go. It's been reserved. It's not going to be given to any other client. It's going to always go to the client who has a specific MAC address. Okay, so I'm just going to put in a made-up MAC address here. This is not real. Oh, mistyped that there. There we go. And the MAC address, of course, is the physical address of the network card of the device. Okay, so the printer has a network card, and that network card's MAC address can be looked up very easily by just telling it to print out a diagnostic sheet. You put that MAC address in here, and what happens is, let me go ahead and click Add and close this window. You'll see I now have this reservation there. Every time this particular printer goes through the DORA process, so it's discovering DHCP servers, it says, hey, I need an IP address. Is there anyone out there who can help me? The DHCP server, this particular DHCP server, will say, yes, I am a DHCP server, and I have a specially reserved IP address just for you. And what that does is it makes it, first of all, that this IP address is not given out to anybody else. It makes it that this IP address is offered out to the printer, but it's a special kind of offer that the printer will know that if it sees offers from multiple DHCP servers, to go ahead and accept this one in particular, because this one has the special reservation for it. And that's how reservations work. And to be more specific than that, or I guess maybe I could be more broad than that would be the right way of saying it, that's how DHCP works. So let me close out of here and tell you that, again, these are probably two of the most common ways to set up DHCP in today's networks, is using either a SOHO router in your home or small office environment, or to use a Windows server. And it may not be a Windows server. If you want to use some other vendor, all server operating environments typically come with a DHCP capability. And so that brings us to the end of this lesson where, well, we learned all about DHCP. And most importantly, with that knowledge, hopefully you won't have to walk around and manually configure any of your IP addresses, unless of course you want to, ever again. So with that, I'll tell you what, I'll see you in the next lesson.